So this video lesson is all about variables, a quick introduction to what they are, how we might possibly use them, and some things that we can do with them first. But before we get to variables, we need to talk about these things called expressions, because a lot of math, especially higher level math and math that we're going to be getting into in the next few years, is based around both the idea of variables and the idea of expressions. And one critical part of expressions are these things called operations. And you're familiar with operations, although maybe not using the term operations. Operations are things like addition, subtraction, multiplication, division, raising something to a power, which is something we call exponentiation, and a whole bunch of other things that fall under the general term of operations. And so one of the critical things that goes along with an expression is that expressions must have operations to go along with them. Now, if the only thing in addition to operations are just numbers, we call that a numerical expression. And you can see here that the word number is a root of numerical, even though we take the B out of it. So a numerical expression is something that contains only numbers of some sort and operations. So let's take a look here at a few examples of numerical expressions to make sure that we've really gotten this idea. All we need is numbers and operations. So something like 3 plus 5 counts as a numerical expression. It has numbers and it has an operation, addition. So this is a numerical expression. 3/4 times 1/2 minus 7. Again, we have numbers, which I'll circle in yellow. We have operations, which I'll circle in green. Numbers plus operations equals numerical expression. So that's the idea behind a numerical expression. Now there are other types of expressions too, and as we said at the beginning of this video, what we're really after is variables. So a variable is something that is completely different from anything you've seen in math up until this point. What a variable is it's a letter that's used to stand in for some unknown value. What we're going to be doing is we're moving from math where we know what numbers we're talking about, maybe substituting the numbers in for particular formulas, doing some calculations and arriving at an answer. And we're starting with one of the most fundamental concepts for most of the rest of math, and that is variables. The fact that we can use a letter, quite literally letters A, B, X is one of the most popular variables, Y. Sometimes we use Greek letters to stand in for variables, theta, alpha, gamma, etc. So just a letter to use for stand in for some value that we don't know. This concept of not knowing and either solving to find for an unknown value or being able to work through a math problem with this unknown value is one of the core concepts of math moving forward. So if we have an expression that has numbers, operations, and variables, we have what's called a variable expression. Again, numbers, operations, and variables. So let's take a look at some variable expressions to make sure that we've really got this concept down. Numbers, operations, variables. So if we have x as our variable, I'm going to use x as our variable pretty much for everything. Because x is one of the most popular variables that we use. It is one of the most common ones that we see. It's one that we'll become very familiar with as we work through math this year, so it's something that I'm going to start using pretty much right away. So an expression involving some operations, numbers, and variables, let's say x plus 7. So we have our numbers, which will be in green, our operations, and our variables. This is a variable expression. Now it's important to note that we know what 7 is and we don't know what x is, but we are okay. Very important. We are okay not knowing what x is. x is some unknown value that maybe we'll find later with solving an equation when we get to it, or maybe we're okay with just letting it be x plus 7 right now, but we have to start being okay with just leaving an unknown as an unknown. And then we'll talk about ways to work through it later on this year. So let's look at another example. We have 3 times x minus 18. So our variable, our numbers, 3 times x really just means 3 times whatever unknown value x is, and our operations, numbers, operations, variables, variable expressions. And so we'll have one more example of this that we can look through, and that will be 1/2 plus x divided by 4. Now it's important, I'm using, instead of the regular division sign, I'm using the fraction bar, which also stands in for division. It's important to know that both the fraction bar and the division sign represent division. So this is 1/2 plus x divided by 4. We have numbers, we have operations, and we have variables. So this is indeed a variable expression. So one thing we can do, which is the last thing I'll leave you with in this video, one thing we can do is write variable expressions from verbal phrases. So taking some words that describe what we're meant to do and writing a variable expression from them. We're going to start out pretty basic with phrases that actually tell us exactly what to write down piece by piece. Throughout the year, we'll get more complicated with how we write variable expressions, but we're going to start off here. So let's look at 2 examples of some phrases. A number minus 6 and 3 times a number added to 12. So there are a few different things that we need to work from here, but more or less, if we just read the verbal phrase from left to right, then we have a pretty good indication of what it is that we need to do to write this expression. So let's start with this one on top. We have this phrase, a number. Anytime we see the phrase a number in one of these, it's going to refer to our variable, which is unknown. It says a number. It means that we don't know what that number is. Again, my variable for these, you are free to use any letter that you want. I'm going to use x. A number here is x. A number minus 6, that's something we're familiar with, so a number minus 6. Again, numbers, operations, variables, variable expression, a number minus 6. Now we're going to get to something a little bit more complicated with the second one here. 3 times a number added to 12. Again, if we read straight from left to right and do exactly what the phrase says, we'll find out how to actually write this phrase as a variable expression. Starting with 3 times a number. Well, times clearly gives us multiplication. I'm going to use a dot because x is going to be my variable, so I don't want to confuse my operation, multiplication, with my variable, x. So I'm just going to use a dot instead for multiplication. So we have 3 times a number. Again, our number is unknown, so I'm going to use x. 3 times x added to 12, so then we add 12 to 3 times x. Again, numbers, operations, variables, variable expression. 3 times a number plus 12. So now is a chance for you to work on it on your own. Go ahead and pause the video and work through here. What I want you to do is I want you to write down the verbal phrase also, and underneath that verbal phrase, write down the expression so you have an idea visually on paper of the phrase and then the expression that comes for it. So go ahead and pause the video, work on these, and resume the video once you're done. So let's start up with number 1. I'm going to use a different variable this time. I'm going to use n, let's say, for number. So the quotient of a number and 16 for number 1. Now, quotient we know means division, so I'm going to write this 2 different ways. The quotient of a number and 16, which can also be the quotient of a number and 16, because as we know, division can be written either as a division sign or as a fraction bar. And we'll use both this year, so it's important to start being able to use both. So this is the answer that we want for number 1 in either of those forms. The difference between 10 and 4 times a number. Now, a difference means we need subtraction. 10 comes first, so we're going to put the difference between 10, which comes first, and 4 times a number, 4 times a number n. The difference between 10 and 4 times a number. So what we want in this case, 10 minus 4n for number 2. Now I have this next one in parentheses intentionally so that it's a little bit more clear what we're talking about. We have 11 plus a number divided by 3. So we want 11 plus, and now here's where we can write it in two ways, a number divided by 3, or 11 plus a number divided by 3. 11 plus n divided by 3 for number 3. And finally, for number 4, the sum of 17 in a number. Very simple, just the sum of 17 and a number. So one more time, let's go through some of that critical vocabulary again. We have expressions, which are critical to math, which involve operations and either just numbers, in which case they're called numerical expressions. If they involve variables, then they are called variable expressions. And what we learned how to do at the end is to take verbal phrases, literally just what is being said in that sentence involving just words, and translating it into whatever variable or numerical expression we want to find.